Screen
Yes, sir.
Yeah.
Yes, sir.
Just a no, 1 minute delay. Okay. So, last class force direction force. Force force convert equivalent force convert okay. So basically, we problem first so I told you angle so it will take some time. I will tell you that. So before that, what we have done, this force system force system force equivalent force okay. Now we have to expand this. For example, this system force convert. Okay. It is basically analysis easy. So once you are done with that concept, let's say there are a lot of forces. These forces this object in either point shift idea. Find the equivalent of this. This force where force some distance A random behavior on this A and this point we are trying to find out. This force and this point. Okay. One particular point or particular force either point force will shift. So what we have to learn to shift this force to any point. Okay. So it is examples. So what we will do is we will study some basic things. Then we will continue to that. Okay. For example, we know what is a couple. A couple and already purchased. So we have let's say we have a road like this. Okay. Or let's say some other shape. Some other shape. We have a shape like this. Or a surface look there. We have two forces. Equal and opposite forces. Okay. So these forces are separated by some distance A. Or let's say D. This is F. This is F. Okay. So this is a couple. Equal forces in opposite direction separated by a distance. Now, if I draw an imaginary line here, I'm just drawing an imaginary line here. So this line is basically perpendicular. Okay. Now, what is E couple? Can I represent it by some other way? So that is my first question. How do I represent this couple in some other way? Okay. Now, for that, what I am doing is I will just take some arbitrary point on this line. Okay. So now, line then we will change. Okay. So let's say I am taking some arbitrary point here. This point is, let's say, this is distance A from this point, and this is A is from this point. Sorry, this will be D minus A from this point. This force. One point. So let's say I'll call this point as capital A. Capital A. Okay. What is the moment about A? We run the forces about A and the point moment. So we will do that. So we will assume anti-clockwise is positive, anti-clockwise positive, and normal convention. Because of this F, F the moment and the force into A. Force into distance is A. It is trying to rotate in anti-clockwise direction. So this is plus. Okay. Now what is this force? Due to second force. Second force also we can say force into T minus A is the distance. Force perpendicular distance from the point. That is the moment. Okay. So this is also anti-clockwise direction. This is also plus. So this is a total moment about A. Okay, so F into A, anticlockwise or positive, F into A, anticlockwise or positive. So this is, if I take F common, A plus D minus A. So this is F into D. This is equal to moment couple. Right. So basically, I am replacing this. Force and try to replace. So let's say, what is the summation of forces in vertical direction? Fy. What is the summation of forces in vertical direction? So that is up positive. Okay. Plus F minus F equal to 0. Okay. So that means, I have to system. Can replace by a zero force and a movement in anti-clockwise direction, F into D. Okay, so E couple karana, the movement is couple net force 0. Okay, so basically this and this is the same representation. Point movement, the behavior of this body and the behavior of this body is same. What is summation of forces in y direction? Here body 0. What is summation of forces in next direction? 0. What is movement about A? It is plus clockwise into force into distance. This is about this body. What about this body? This body we will summation of forces in y direction equal to 0. Summation of forces in x direction equal to 0. Movement about A equal to force into distance. This same about this point. All forces the sum 0. Direction of force in the sum 0. Movement in M in F into D. This both are equivalent system. Now, again we'll take that body. Okay, again we'll take that body. Now let's say I'll remove this. I'll take some point here, B. Okay, now let this B be at distance B from here. Okay, so for this system, about B I am seeing, okay, what is the movement about B? Movement about B. What is the movement about B? So how do you find each force? I will take force into perpendicular distance. So anti-clockwise is my positive. Anti-clockwise is positive. Okay, but E force this force into B is my clockwise rotation. So F into B. F into B, it is in clockwise direction. So I have to put a minus n. Minus of F times B. Now, what about the second force? Second force about this point moment in the rainbow. Force times, what is the distance? D plus B. B plus D. Okay. It is trying to rotate in anti-clockwise direction, so it is positive. Okay. So minus FB plus F into B plus D. This also I can expand. FB plus FD. So EFB have been cancelled out. This will be F into D. This is equal to moment due to couple. Moment due to couple. Right? Now, what is the summation of forces in x direction? 0. Summation of forces in y direction equal to 0. This is 3 I can I can say the system I am replacing the system. Okay. Now, so that means I can also represent by area moment. So this is net moment is anti-clockwise direction. Okay, E system same one. കാരണം by summation of forces in x equal to 0, summation of forces in y equal to 0, moment about d equal to f into d. Clockwise direction, positive. Okay, so it is same one. So basically, if I represent it like this, it is same. If I represent, so either point, object in there, either point. Either point in the moment, any point I take, I can write it is empty. Okay. This one is here line. Okay, so this is basically couple equivalent movement represent. Now why am I doing it? Because we have to connect together. One pala force force equivalent force. All forces are force. And a couple on the couple number where represent. You can represent it by some. Okay. Now what if you take at some other point? Some other point here point at the you can calculate this distance. You can still see that it is in same moment. Off the plane where the point we will see now. Okay. Now what if I ask you, what if I ask you, there is a road here, there is some force here, some force here. Okay. Now let's say this force is 10 kilometers. Okay, so this distance is, let's say, 3 meters. This distance is, let's say, 4 meters. Okay, so I would say replace this force. So this is, let's say, A, B. Replace this force by A, force and couple at A, B. Okay, so replace this by some force and couple at A and B. So couple in the rainbow, you can see, you can replace by this or you can replace by this. In a moment, it is coupled. Okay, so in the ultimately what you need is, first one is you need something like this. So question is asking you to find. So some force, I don't know what is the value of force. If we force in to transfer, I don't know what is a force, and there will be some movement. First question. Second question, second part is basically asking us to do the same thing for B. Something else. I don't know. Sense on the clockwise and anti-clockwise. This is A, this is B. Okay. So what it is telling is E system, E system, E system. All these three systems is same. So this, when I write a moment, you can say that moment it is a moment or it is a couple. We can say it is also a couple. Okay, because we have already seen that this couple can be represented by this. This couple can be represented by this. Same one. Okay, now two questions. How do you transfer to here and how do you do this? The question. Okay, now conditions is, if these two, let's take these two cases. So this is, I will take case I or 1, case 2, case 3. Now for systems to be equivalent, summation of forces in X in system 1 should be equal to summation of forces in X in system 2. Summation of forces in y direction in system 1 should be equal to summation of forces in y direction in system 2. Moment about some point, let's say A, should be equal to moment about A. This is system 1, this is system 2. Okay. System 1 A moment ആണ് അത് system 2 moment. But ഈ മൂന്ന് കണ്ടീഷൻ സാറ്റിസ്ഫൈ ആണെങ്കിൽ നമുക്ക് ഈ എന്താ പറയുക റീപ്ലേസ് ചെയ്യാൻ പറ്റുള്ളൂ. അപ്പോൾ ഇത് റീപ്ലേസ് ചെയ്യുന്നത് വെച്ചാൽ ഇറ്റ് ഹാസ് ലോട്ട് ഓഫ് നമുക്ക് പ്രാക്ടിക്കലായിട്ട് ഒരുപാട് ഉപയോഗങ്ങളുള്ള ഒരു പരിപാടിയാണിത്. അപ്പോൾ ഇത് ദിസ് ഇസ് ബേസിക്കലി ആൻ ആക്ഷൻ. സോ നമ്മൾ പ്രോബ്ലം സോൾവ് ചെയ്യാൻ വേണ്ടി നമ്മൾ പ്രോബ്ലംസിനെ സിമ്പിൾ ആക്കാൻ വേണ്ടി ചെയ്യുന്ന ഒരു രീതിയാണ്. സോ സിമ്പിൾ ആക്കുന്നത് വെച്ച് കഴിഞ്ഞാൽ ഇതിന്റെ അൾട്ടിമേറ്റ് ഉദ്യോഗം വരുന്നത് വെച്ച് കഴിഞ്ഞാൽ ലെറ്റ്സ് സേ വി ഹാവ് ലോട്ട് ഓഫ് ഫോഴ്സസ്. ഓക്കെ, ഈ ഫോഴ്സുകളുടെ ഒക്കെ it is difficult to find. There's a moment. So for example, നിങ്ങളൊരു ബിൽഡിംഗ് എടുക്കുക, ഒരു വീടോ എന്തെങ്കിലും ബിൽഡിംഗ് എടുക്കുക. അപ്പം ആ ഒരു ബിൽഡിങ്ങിന് ലെറ്റ്സ് സേ there is a roof like this. പക്ഷെ നിങ്ങളുടെ ഒരു കാർ ഷെഡ് ആണ് കരുതുക, അല്ലെങ്കിൽ നിങ്ങളൊരു ബ്രിഡ്ജ് എടുക്കുക, ബ്രിഡ്ജാണ് ഒരു ബ്രിഡ്ജാണ്. ബ്രിഡ്ജിൽ കുറെ ലോഡുകൾ ഉണ്ടാവും. ചിലപ്പോൾ ഒരു മനുഷ്യൻ പോകുന്നതായിരിക്കും, ചിലപ്പോൾ ഒരു ബസ് പോകുന്നതായിരിക്കും, ഓക്കെ, ചിലപ്പോൾ വേറെ എന്തെങ്കിലും പോകുന്നതായിരിക്കും, ഒരു മോട്ടോർ ബൈക്ക് പോകുന്നതായിരിക്കും. ലോട്ട് ഓഫ് ലോഡ്സ്. അപ്പം ഈ ലോഡുകളെ ഒക്കെ നമുക്ക് ഇതിന്റെ ഒക്കെ ഫോഴ്സുകൾ, സോ ദിസ് ഫോഴ്സുകൾ നമ്മൾ വരയ്ക്കുകയാണെങ്കിൽ ഇഫ് ഐ ഡ്രോ ദ ഫോഴ്സസ്, ലോട്ട് ഓഫ് ഫോഴ്സസ് ഇങ്ങനെ ഫോഴ്സുകൾ ഉണ്ടാവും. ഈ ഫോഴ്സിനെയൊക്കെ എല്ലാം കൂടെ if I am able to simplify it with some force and some moment, it is easy for my calculation. In the calculation, easy I can extract it. So that is why we are studying all these things. Okay. Now, within the basics, the second year using, the third year using, the fourth year using, everything you will be using this. So it is very important that you understand this carefully. So, question is, replace this force with a force and a couple at A, with a force and a couple at B. Then replace it. Okay. Now we will solve this. Solve it. So let's say we'll take these two. Okay. Now, what is the force? Let's say we'll take this point. A answer. What is summation of? So system 1. System 1 or case 1. Okay, system 1. What is summation of forces in y direction? Up positive. Equal to minus 10 kilonewton. Earlier, that forces downward minus 10. What is summation of forces in x direction? So let's say right positive equal to 0. What is moment about A? Anti-clockwise positive. So moment about A is 10 into 4. It is trying to rotate in clockwise direction, so it's negative. Equal to minus 40 kilonewton meter. Now the same thing should happen to system 2. System 1 and 2 ഇതേ കാര്യങ്ങൾ തന്നെ സംഭവിച്ചു കഴിഞ്ഞാൽ നമുക്ക് സിസ്റ്റംസ് ഇക്വലന്റ് ആണെന്ന് പറയാൻ പറ്റുള്ളൂ. So system 2. System 2. System 2 will, okay, I don't know what is this. We have to convert to some force and moment. Okay. So ഞാൻ അവിടെ ഒരു ഫോഴ്സും ഒരു മൂവ്മെന്റും ഞാൻ മാർക്ക്. So I have marked it like this. I can mark the other way also. Let's say I have marked it like this. Summation of forces in y equal to 0. അപ്പോൾ ഇവിടെ ഏതാണോ സൈൻ എടുത്ത് ആ സൈൻ തന്നെ ഞാൻ ഇവിടെ ഫോളോ ചെയ്യണം. I have to follow the same sign convention. Okay. So fy equal to 0. What is fy? It is equal to minus f. Okay. F ആണ് ഞാൻ ഇവിടെ ഫോഴ്സ് അപ്ലൈ ചെയ്തത്. ഞാൻ റാൻഡംലി അപ്ലൈ ചെയ്തതാണ് ഫോഴ്സ്. A എന്നോ B എന്നോ എന്ത് വേണമെന്ന് കൊടുക്കാം. I'm just applying f. So I'll call this as FA, for clarity, equal to minus FA. Okay. Now what is summation of forces in x direction should be equal to. So this is equal to. If I apply some force here, let's say I'm applying some force also here. FAX equal to FAX. എനിക്കറിയില്ല acceleration force വരുന്നത്. I'm just telling it is acceleration force ഉണ്ടാവും. Plus ഞാൻ ഇവിടെ ചുമ്മാ മാർക്ക് ചെയ്യാം ഒരു ഫോഴ്സും ഒരു ഇത് കൊണ്ടൊന്ന് ഞാൻ മാർക്ക് ചെയ്യാം. Now what about movement? Movement about same point. Anti-clockwise positive. About this point, anti-clockwise positive. So FA into 0 plus FAX into 0 minus M at A. So this is, let's call this as M. Yeah. Okay. Some force FA, some horizontal force FAX, and some moment here. Now I have to keep on equating these two. Then equate. Okay, what I will get? So when I equate these two, what I'll get is minus 10 equal to minus FA. So this implies FA equal to 10 kilonewton. Okay, so that means so FA ഞാൻ ഉദ്ദേശിച്ച ഡയറക്ഷൻ തന്നെയാണ്, അല്ലെങ്കിൽ നിങ്ങൾക്ക് മൈനസ് സൈൻ കിട്ടുമായിരുന്നു. So this is vertical 10 kilonewton. Okay, now what I will do, I will equate these two. FX. So 0 equal to FAX. So that means FAX is 0. E value is 0 on. This is not there. 0. Now if I equate these two, what I'll get is minus 40 equal to minus M. So M equal to 40 kilonewton meter. So I will direction direction. So this is 40 kilonewton meter. Okay, so this is how you convert a force to another force. If you the E system, it is behaving in the same. E system, whatever. If this is a couple, if 14 and replace it is basically a couple, but I am representing it like this. Okay, yeah, some. But couples couple confusion. You just assume this to be a moment. Okay, so E system will be behaving. E stick, whatever behaving. Otherwise, E stick 10 kilonewton force apply. Okay. It will behave somehow. Other than ഞാൻ ഇവിടെ 10 kilonewton ഒരു 40 kilonewton meter movement കൊടുക്കുന്നതിന് സമമായിരിക്കും. So this two are equal. Okay. Now what about the previous one? Let's say we have to find case 1 and case 3. Okay. So equivalent force നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യുമ്പോൾ ഫസ്റ്റ് എന്താ നമ്മൾ ചെയ്യേണ്ടത് വെച്ച് കഴിഞ്ഞാൽ assume some forces and moments. I don't know what is the direction I know. Then assume some direction. Let's say it will be downward. It is force in B. Let's say there is a horizontal force also. Force in B next direction. Let's say there is a movement also. Movement M dash. Okay. No. System case 1, case 2, or system 1, system 2. Case 1, case 3. Okay. What is summation of forces in X direction? Right is positive. 0. Currently there is no X direction force. What is summation of forces in Y direction? Up positive. What is this? Minus 10. Only minus 10 is there. What is movement about B? Because I am trying to shift to move B, so I have to find movement about B, anti-clockwise positive. So this is force into distance. It is trying to rotate in anti-clockwise direction. So 10 into 3 with a minus 7 equal to minus 30 kilonewton meter. Right. Now what about case 2? What is summation of forces in X direction? So right is positive. So this is minus FPX. What is summation of forces in Y direction? Up is positive. It is minus FB. What is movement about B? Anti-clockwise is positive. So anti-clockwise, it is clockwise. minus m. Okay, so this, sorry, this is this is anti-clockwise, so this will be positive. Okay, right. Now what I will do, simple, equate this. Equate here. So first what I will do is I will equate these two. So when I equate those two, what I get? 0 equal to minus fbx. So that means my fbx is 0. Okay. So whatever force is here in this direction, it is 0. So I can remove that. Now what I'll do? I can equate these two. Okay. So minus 10 equal to minus fp. So this is this. Fp is equal to 10. Okay, b is equal to 10 or equal here. 10. Now the last equation, I have to equate this. Okay. That gives me 30 equal to minus m. So this means m equal to minus 30 kilonewton meter. Now, minus 30, don't confuse it with anti-clockwise or clockwise. We assume the direction, the opposite direction. I assume that, so it should be in this direction. Okay, so this and this is equivalent. Okay, any doubts here? Any doubts here? Doubt on so basically force okay, so basically thinking on the examples, okay, complicated design exams are, so I think of some simple examples. Okay, just give me something. So this is basically how do you do that? Okay, it's multiple forces ഒരുപാട് ഫോഴ്സുകൾ ഉണ്ടെങ്കിൽ നിങ്ങൾക്ക് ഇത് ചെയ്യാൻ പറ്റും. ഈ ഫോഴ്സിനെ എങ്ങനെയാണ് ഓരോ ഡിഫറെന്റ് മൊമെന്റുകളും ഫോഴ്സുകളാക്കുന്നത്. So for example, what you can do is after some practice or some examples, what you will be able to do is നിങ്ങൾക്ക് ഒരു ബോഡി ഉണ്ട്, there are a lot of forces. Okay, ഇതിനെയൊക്കെ you can convert to some force F, and a moment. Convert it. Okay, you will be able to do that. Or even a simple case പറയുകയാണെങ്കിൽ നമുക്കറിയാം, നമുക്ക് collinear points ആണ് നമ്മൾ അനലൈസ് ചെയ്യാൻ പഠിച്ചിട്ടുള്ളത്. Okay, so what you can do is ഈ ഫോഴ്സുകളെല്ലാം, so if you take a point here, you find the perpendicular distance, find the perpendicular distance. Okay, this point, so this is the point. You can convert this force into some force and moment. You can convert this force into some force and some other moment. You can convert this force into, let's say, some other force like this and some moment. I don't know, something like this. This force into this force and this moment. Okay, അങ്ങനെയാകുമ്പോൾ എനിക്ക് co-linear അല്ലാത്ത ഫോഴ്സുകളെയൊക്കെ co-linear ആക്കാൻ പറ്റും. with an additional moment. അപ്പോൾ ഈ ഫോഴ്സുകളെല്ലാം ഇത് ഈസ് ടു ഒരേപോലെ. It will be easy for us to analyze. Okay. So we will do. So what I will do now is I will do one more example. Some more complicated examples we will do. It may be നിങ്ങൾക്ക് മനസ്സിലാവുന്നില്ലെങ്കിൽ don't worry, don't give up. What you have to do is you have to keep trying. You can try ചെയ്യുക എന്നതാണ് എൻ്റെ essence. If you have a mind to try, it will be very easy. Otherwise, it will be very difficult for you. Okay. So let's see. Let's say I will increase the difficulty level. I will ഞാൻ തന്നെ solve ചെയ്തുതരാം. So let's say we have a force here, 8 kN. Let's say we have another force here. Let's say we have another force here. Let's say we have another force here. Okay. So let's say this is, let's say 10 kN. Let's say this is 7 kN. Let's say this is 8 kN. Let's say this is 12 kN. Okay. Let's say this is 3 meters. This is also 3 meters. This is 4 meters. Now the question is, convert all these forces into an equivalent force, or observe the system. System given. Okay. Simplify it. To a force and couple. So let's say I'll call this as A couple at A. Okay, base system is simplified to a force and a couple. So you have a lot of forces. What you have to do is ultimately what you have to do is what I need is a force and a couple. So let's say I need a force like this. I don't know. Some force like this, some force like this, some couple like this. I don't know what is the direction. Approximately. You can apply it upward also. So let's say I call this as FAY. I call this as FAX. I call this as M. Okay. This is my A. Okay. So this is my case 1 or system 1. This is my case 2. Is it same idea? Both of these two should behave in the same way. How do you do that? Okay, same simple idea. About this point, this system, whatever is the net force in the upward direction should be equal to net force in vertical direction. Whatever be the net force in horizontal direction should be equal to whatever be the net force in horizontal direction. It is as simple as that. Simple item. Okay. After this, we will complicate this a little bit. Then we will do. Okay. In the system case 2, how do you do that? If you want to try, or I will try this. It is a little complicated. Maybe I will try to solve this. Okay. So what I do is I drop this. I need some space here. Now let's say case 1. Let's say case 2. Okay. Systems equivalent and then the net forces in next direction should be same in both systems. Net forces in y direction should be same in both systems. And net movement also should be same about the point which you are considering. Okay. So what is summation of forces in x direction taking right as positive? How much is that? So this is 0 because there is no forces in x direction or component of forces in x direction. What is summation of forces in y direction? Up positive. Okay, generally it is good to consider this as my positive system, x, y, m. Okay, so this is what, let's say Fy. So there is a 10 upward, so it is positive 10. There is a 7 downward, so it's a minus 7. There is a 8 downward, so it's a minus 8. There is a 12 upward, so it's a plus 12. So how much is this? From plus 3, 5 minus 5, 7. Is it 7? Almost 7 kilometers. Okay, 7 kilometers. This 7 kilometers. Okay. Now what is moment about A? Moment about A. Okay. So all force in the moment about A. So I'll just call someone. Let's say Bipin Jacob. Bipin Jacob undo. Bipin Jacob. Bipin Jacob. Abhishek Vinod. Abhishek Vinod. നിങ്ങൾക്ക് ചാറ്റ് ചെയ്യാൻ ബുദ്ധിമുട്ടുണ്ടെങ്കിൽ you have to put in the chat. Okay. Abhishek Vinod.
സാർ അറിയത്തില്ല.
എന്താ ചോദിച്ചേ?
സാറാ മനസ്സിലായില്ലേ?
ഞാൻ എന്താ ചോദിച്ചത്? മൊമെന്റ് എങ്ങനെ കണ്ടുപിടിക്കുക? പറഞ്ഞോളൂ. ഈ പോയിന്റ് അബൌട്ട് എ പോയിന്റ് മൊമെന്റ് എങ്ങനെ കണ്ടുപിടിക്കുക? ഓരോ ഫോഴ്സുകൾ തമ്മിൽ. What is the moment about A due to this force?
Force into distance of.
അപ്പൊ എത്രയാണ്? പറഞ്ഞോളൂ. എത്രയാണ്? 10 കിലോമീറ്റർ ആണ്. അബൌട്ട് ദിസ് പോയിന്റ് ആണ്. അപ്പൊ എത്രയാണ് മൊമെന്റ്?
10 into 0 ആണ്.
10 into 0 ആണ്. Okay, so that is 10 into 0. അടുത്ത ഫോഴ്സ്
7 into 3.
Clockwise or anti-clockwise?
Clockwise.
So it is plus or minus? My anti-clockwise is plus.
Minus.
Minus. So it is minus 3 times 3. അടുത്തത്
minus 8 into 6.
6. അടുത്തത്
plus 12 into 10.
10. എത്ര എന്റെ വാല്യൂ പെട്ടെന്ന് കാൽക്കുലേറ്റ് പറഞ്ഞേ?
സാർ 3 times 7 അല്ലേ?
7 അല്ലേ ഫോഴ്സ് ചെയ്തത്? ഓക്കെ, സോറി, ഞാൻ എഴുതി വെക്കാം. 3 ടൈം പറഞ്ഞ കറക്റ്റ് ആയിരുന്നു, ഞാൻ എഴുതി വെക്കാം. ഓക്കെ, എത്രയാണത്? So just give a moment. So anti-clockwise positive 10 times 0 minus 7 times 3 minus 8 times 3 plus 12 times 10. എത്രയാണത്? കാൽക്കുലേറ്റ് ചെയ്യും, പെട്ടെന്ന് കാൽക്കുലേറ്റ് ചെയ്യും. ആര് പറഞ്ഞാലും കുഴപ്പമില്ല, വേറെ ആക്കി കിട്ടിയാൽ കുഴപ്പമില്ല.
51.
51. Always write units, okay? Kilonewton meter. Kilonewton meter. Now, let's say about this second. Okay, Harishankar mute you, and Sanjeev Harishankar mute you. So summation of forces in x direction. So here same convention I have to use now. Okay, right positive. So this is for case 2. So this is case 2. Case 2 in FAX ആണ് force in x direction. X direction. Okay. Now what is summation of forces in y direction? Up is positive. Okay. So that is minus F A y. Now what is moment about A and the clockwise positive? The moment about A is F A y into 0. F A x into 0 plus MA. So I should not write MA. MA confuse our icon. So I'll write something else here. So let's say I'll call this as ME. M equivalent in the ME. Let's say ME. I don't know. M, just like that. So this is basically plus ME. Okay. Now we have to just equate this. Equate it. Simple task. So you have to equate these two. We have to equate these two, and we have to equate these two. Okay. First we will equate the first one. Equating X forces. So equating X direction forces. So 0 equal to Fax. So this gives me Fax equal to 0. Okay. So that is there. So this is 0. This is 0, X direction. Okay. Now equating Y direction. Okay. Y direction is 7 equal to minus Fay. So this means Fay equal to minus 7 kilometer. Now what is the meaning of this? Okay. I have assumed it to be in this direction. But answer is telling me it is in minus direction. So E direction and the opposite direction is force. So this is how we have to write. Okay. So if minus E or minus E direction or confuse here, if negative, final solution negative, you will assume the direction and the opposite direction force in the mind. Okay. So is it right? Let's see the okay. Down. Okay, correct. So 7 kilometer upward. Okay. Now what do we have? Equating moments. Equating moment. Okay. So 51 equal to M. So this implies M equal to 51 kilometer meter. Now this plus direction. So movement will be in this direction. It is 51 kilometer meter. Now this is the equivalent system. This is the system. അതായത് ഇത്രയും ഫോഴ്സുകളൊന്നും നമ്മൾ ചെയ്യേണ്ട ആവശ്യമില്ല. നമ്മൾ ഇത്രയും ഫോഴ്സിനെ മാത്രം ഈ സിസ്റ്റത്തിൽ അനലൈസ് ചെയ്ത് കഴിഞ്ഞാൽ അപ്പോൾ സിസ്റ്റത്തിൽ റൊട്ടേറ്റ് ചെയ്യോ നീങ്ങുമോ എന്നൊക്കെ ഇത്രയും ഫോഴ്സുകൾ കൊണ്ട് മാത്രം നമുക്ക് അനലൈസ് ചെയ്ത് കണ്ടുപിടിക്കാൻ പറ്റും. Okay. So this is what you mean by equivalent system. So it is basically simplification procedure. നമുക്ക് basically simplify ചെയ്യാനുള്ള ഒരു tool ആണ്. Okay. So I hope this is clear. Any doubts here? എന്തെങ്കിലും doubt ഉണ്ടോ നിങ്ങൾക്ക്? Now, if you have forces in inclined direction, that also I'll tell. So let's say, so easy force. Okay, let's say one force is in this direction. Let's say some forces in this direction. Some theta. Okay, so what you have to do is, if the forces are in inclined direction, what you have to do is, you have to first make it simple. Simplify here, then it will be easier for you. E force in the X direction, Y direction. Okay, so this is 8 sin theta. 6, 8 cos theta. Again, split it will be easy for you. Angle force. So ultimately, now you think I have 3 forces like this. Okay, 3 forces. Let's say this is some angle of the motion. Let's say this is 12. This is 15, this is 20, this is 60, 60 equivalent. Okay. അങ്ങനെയാണെങ്കിൽ ഈ സിസ്റ്റത്തെ മുഴുവനും എനിക്ക് എൻ്റെ സെൻട്രലോ അല്ലെങ്കിൽ ഈ ഒരു പോയിന്റിലോ ഈ ഒരു സിസ്റ്റത്തെ മുഴുവനും So this ഇങ്ങനത്തെ ക്വസ്റ്റ്യൻ നമ്മൾ സോൾവ് ചെയ്യും. നിങ്ങൾ ഇത് ചെയ്യാൻ പറ്റണമെന്നില്ല. ബട്ട് ഇറ്റ് ഈസ് ഗുഡ് ഇഫ് യു ക്യാൻ തിങ്ക്. നിങ്ങൾക്ക് അത് തിങ്ക് ചെയ്യാൻ പറ്റുമെങ്കിൽ ഈ ഒരു സിസ്റ്റത്തിന് മുഴുവനും മേ ബി സം ഫോഴ്സ്. I don't know what is that force. So let's say about this point. ഈ പോയിന്റിലെ ഒരു വെർട്ടിക്കൽ ഫോഴ്സും ഒരു ഹൊറിസോണ്ടൽ ഫോഴ്സും ഒരു മൂവ്മെന്റും ആക്കി ഇതിനെ മിനിമൈസ് ചെയ്യാൻ പറ്റും. സോ ദാറ്റ് ദിസ് ബോത്ത് ആർ സെയിം. ഇത് നിങ്ങൾക്ക് ചെയ്യാൻ പറ്റുമെന്ന് നിങ്ങൾ ആലോചിക്കുക എങ്ങനെയാണ് ചെയ്യുന്നത്. ഓക്കെ. So imagine that first you think about this, then you think about this. Everything is we are doing the same basic principle. This is system 1, this is system 2. ഇതിന്റെ y x directional force കണ്ടുപിടിക്കുക. അപ്പോൾ ഇതിൽ നിങ്ങൾ ചെയ്യേണ്ട അത്രേ ഉള്ളൂ. നിങ്ങൾക്ക് ഇതിന്റെ x directional force ആക്കുക, y directional force ആക്കുക, അല്ല x directional ആക്കുക, y ആക്കുക, ഇതിൽ x ആക്കുക, y ആക്കുക, ഇതിൽ x ആക്കുക, y ആക്കുക. എന്നിട്ട് കോമ്പണൻസ് അനുസരിച്ച് നിങ്ങൾ രണ്ടിന്റെ കോമ്പണൻസ് സെയിം ആക്കുന്ന രീതിയിൽ നിങ്ങൾക്ക് ചെയ്താൽ മതി. ഓക്കെ. So I leave to this. Think doubts uണ്ടെങ്കിൽ you can ask me now. Otherwise what I'll do is, yeah, if you have any doubts you can